When you build applications, you typically start by using the high intelligence AI models to help you solve a problem or a task. And after that, you start refining the prompts and you make sure that they are stable, even if the user data or behavior changes. But over time, as a developer, you might want to reduce the costs or reduce latency in your application. Sometimes there is a task that maybe calls many models multiple times, and if you're using the highest intelligence models, costs add up and latency could potentially become an issue. So OpenAI since October has allowed us to optimize for these type of situations, whereby we can distill a smaller model based on the output of a larger model. So in this video, we're going to see how this works. We're going to take a wine data set, a simple data set, and we're going to try to predict the variety of the wine based on some characteristics from the data set. We're going to first see the performance of GPT-4o and GPT-4o mini on a data set of 500 samples, and then we're going to fine-tune a model based on the outputs of the bigger model of GPT-4o, and then we're going to see if we are able to match the performance with a distilled but much smaller model. So let's look at the code. Okay, we are in Cursor here. Let's have a quick look at the data set. We have a training data set of 500 samples. It's basically, you get information like country description, designation, points, province, region, winery, and variety is the one variable which we will try to predict. And we also have set out a validation data set that's completely separate from this, of 300 samples to check that the fine-tuning works. That's typically what you do in data science and ML, so that you don't have the issue that you have overtrained on just your training data, but it fails to generalize or apply to data outside of that distribution. We're going to work with two files. First one to orchestrate getting the outputs, because we're going to have 500 and then 300 calls for each model to OpenAI, so that's quite a few calls, and then we're going to analyze the results. Ignore the first file. I was just to show so that I can see the data. But let's go to the output orchestration. Here we set up the interfaces, so wine records, that's the stuff that we saw in the data set. Prediction result, we're going to also set up an object for saving the variety, but also the ground truth, because we're going to compare the two when we analyze the data. So these are the paths for the data sets. Then we generate the prompt. It's a basic prompt based on this wine review, guess the grape variety, and then we give all these different data points and descriptions. And here's a list of possible grape varieties to choose from. We're in the variety list. What is the likely grape variety? Answer only with the grape variety or blend from the list. So we have a helper function to get unique varieties from the data set. Then we have a function to get the prediction, which will call GPT-4o, GPT-4 mini, or the fine-tuned model. We pass it in the model prompt. Response format is basically the schema or the output format that we want, because we're going to use structured outputs. If you don't know about structured outputs, check out a previous video I've done on that. I'm only using structured outputs because it's really much easier to work with and much more consistent. We're going to have a timestamp so that we can record when the run has started, and we can find it in the OpenAI portal. We're going to store completions when we do the first run on the training data set between GPT-4o and GPT-4o mini. We're going to store GPT-4o's results, because these results will be the ones we use to train or distill the smaller model. So it's true when we get GPT-4o and we're training. And yeah, we have some retries and rate limit kind of mechanisms so that we don't hit rate limits. Depending on your tier, there are different rate limits. You can find them in the OpenAI developer portal. So if you're tier 1, for example, under $50 of spend, you might get hit by these 30,000 tokens per minute, which is quite restrictive. But if you're on tier 2, then it should be fine. I've spent the runs to be fitting that tier 1, so hopefully it should be okay. There might be 1, 2, or 3 items that we don't get a completion for, but in the grand scheme of things, like 3 out of 500 not completed is fine for me. So I just put a reasonable rate not to have it wait too long, but also not to hit those rate limits too often. Then we have a system prompt. You are a sommelier expert. You answer precisely with the name of the variety or blend. And here is the completion call. We use OpenAI beta.chat because it's structured outputs. The response format is that ZOD response schema format. Should store will be true when we train, not true when we are validating. And then we have some metadata so that we can find that training data with purpose and timestamp. And that's it. And then when you work with structured outputs, it's useful to know that the message can include the result, but also if the model refuses, there is a message.refusal which you can check and then throw an error. Sometimes, there's sensitivity issues, so you might want to rephrase maybe some data. So it's useful to know that you have an error that's due to a refusal and not an API or server error. And then we have like a orchestrator function that processes all of this data in batches. So all that it does here is really split it into different batches and run the output. So that's all of this basically, which you can look at your leisure. I'll put the link to all these files on GitHub, of course, and you can find the link below in the description. Yeah, so for testing, you can specify the number of samples if you want to just test for 3 items to see that everything is working, and then it's -1 if you want to process the whole batch. And this is basically the loop that goes through the batches with some output items. Then analyzing results is pretty basic. We're defining the outputs, and then we're going to just calculate accuracy. If the prediction is equal to the actual variety or not. So that's pretty easy, pretty binary outcome. Then we just have some helper functions. Everything is saved in the data folder, both the predictions and then the analysis, and then we get a nice output which will tell us the results. These 2 files are orchestrated here. So to run the analysis, we just do pnpm tsx to run TS files, then the path to the file, it's in source, and then we need to specify the model. Is it either GPT-4o mini or the distilled model that we're going to run against GPT-4o? What data set we use, train or validation? The file has the ability to allow you to just run a small sample to test. So if you put 3 instead of -1, we're just going to run 2 data samples for each of GPT-4 and mini. Yeah, no, three samples for each. So you see here the output means that it's been done on the 3 of them, 100% accuracy. So things look good, and then you can just replace the 3 with -1, and then you're good to go. So let's see what happens when we run a full batch. Okay, so we've run the first analysis, and so the results are here. GPT-4o got 83% of the predictions right. GPT-4o mini got 74.4%. So we've got 8.6% gap. Now, what we're going to do is we're going to distill a GPT-4o mini model based on the outputs of GPT-4o. So in the completion, we had this purpose and timestamp metadata. We're going to use that now. We go to the OpenAI dashboard on the developer platform, and we go to chat completions, and then this is where we can put, for example, the model GPT-4o, and then the metadata we've just seen. So we had purpose, wine, classification, and then we had the timestamp, which is equal to one of these file endings. So 16th of December, 12:05 p.m. and we apply. Then we're gonna get 507 completions. And so there is this button, distill, which we're gonna click. The default settings should suffice. We just need to make sure we check the mini model so as not to have the wrong model and then it becomes costly. So it's the GPT-4o mini. Everything else should be as default, and we're going to create a new model distilled on the outputs of the bigger model. Let's go. Okay, so the model has finished fine-tuning. It took about half an hour. So you see, succeeded the status. The output model ID is going to be important. That's the one we're going to refer to in the completion code. When we call OpenAI, we need to give a model. Usually we give GPT-4o or GPT-4 mini, but we're going to give this a long string. So we're going to run now this new model on the validation data set and then check how it does compared to GPT-4o. So let's just get this to run and let's see the results. Okay, so the batches have finished running. Remember the initial data set used for training, GPT-4o was outperforming GPT-4o mini by 8.6% on around 500 data samples. And we're going to check how this new distilled GPT-4o mini does on the validation data set of 300 samples. So, ta-da! All right. And this is very interesting because basically GPT-4 mini is performing at the level of GPT-4o here. We are about 75-76%, which is very surprising because I thought the gap would be lower, but not that mini would exceed GPT-4o. Of course, there is it's just a different data set, so you won't get the same performance, but relatively wise, fine-tuning has worked. So you're gonna get a similar performance for a much lower price and much higher speed. So this was a simple example of how to fine-tune a smaller model based on the output of a larger model. So hope this was useful. Happy building!